Hello, Data Standard community. I am your host, Shayna Weldon, and this is the Data Standard audio experience. We have a great guest today on our podcast. We have Sean Gupta, a data science consultant at Sixth Root. He's an experienced data science and machine learning consultant with a passion for delivering real-world commercial research and product solutions. Today, we're speaking about data models. Welcome to the show, Sean.
Hey, thank you. Nice to meet you. How are you today?
I am doing great. Thank you for being here. Yes, to start off. Yeah, please, just to start off, go ahead and introduce yourself.
Sure. Right. So my name is Sean. I've been working in the data science industry for the past 2 years. So originally my background is in mathematics. So I did my undergrad in maths and then a master's as well. And I focus a lot on probability and statistics. I had no idea what machine learning was or data science, in fact. I just knew something about AI. Then I came across a machine learning course on Coursera. I'm sure like a lot of people will know this course. It's a course taught by Andrew Ng, the machine learning course. It's like one of the most popular ones on Coursera. And yeah, that's how I made the connect to machine learning, because as I found out, it's very closely related to statistics. And you could say machine learning is the sexier version of statistics. And so, yeah, it sounded good to me. So I decided to go into that area. And in fact, I did another master's degree in machine learning, where I felt like my mathematical background knowledge was quite useful. And it was also useful to already know some coding. So I was by no means a software developer before. And I would say in my course, I learned like some basics, but most of the software development that I know now, I learned actually afterwards in practice. So after completing that, the master's degree in machine learning, I decided to do an academic research project where I had access to police data from a police force in the UK. And we were trying to classify domestic abuse reoffenses. So the idea is there is a call to the police from let's say a victim of domestic abuse or potential victim, and the police has to make a risk assessment. Okay, is this going to be a serious case or not? And this is where machine learning can come in to improve that risk assessment. Afterwards, I worked for a company called SenseSign Health. What they do is, one of their major projects was looking at anonymized patient healthcare records and trying to derive clinical insights from those records. So essentially applying clustering algorithms to certain patient cohorts, let's say all patients who suffered from a stroke and were admitted to a particular hospital in the UK. And once you have clustered the patients into different groups, you can see, are these groups clinically meaningful and can they inform future drug development? Because drug trials are super expensive. And if there's any way how you can cut costs or reduce sample sizes, that's obviously very beneficial. What I'm doing now is, once again, I changed track quite a bit. So I'm working at a company called Chambers and Partners. What they do is they rank law firms around the world. So for example, if you think about the top law firms advising on M&A in New York, then Chambers would have a ranking table for those law firms. And I essentially came in as someone who knows something about data, what data science, if you want to call it. And I'm trying to make use of the data that exists within the business in order to improve pricing models, as well as to get an idea of who our customers are. So essentially to do a customer segmentation. So yeah, that's me.
Wow, that is a very impressive background. I know you mentioned the public sector service, specifically the police force. So regarding risk assessment, I know it's traditionally done by human judgment. So what are some new technological advances in this area that is creating less bias?
Right. So in the UK, how risk assessment in domestic abuse typically works is there's going to be a first point of contact. Let's say there's a couple, and then the victim calls the police and reports like, okay, there's trouble at home. Let's say the responding officer would typically ask a series of questions. So there's a questionnaire called the DASH questionnaire, which consists of 28 questions. And they include things such as, are you frightened? Or is there conflict about kids? Those kinds of questions. And on the basis of those responses, as well as the kind of police officer's own judgment, the officer would give a risk score that's essentially in 3 bands. So there's standard risk, there's medium risk, and there's high risk. This is important in the future when another call comes in. Let's say 2 months later, there's trouble again. Essentially, the police has to make a decision. Do we send an officer to that couple or not? And resources are, of course, limited, especially with cuts in the recent years to police services. And so you can't send an officer every single time. There are kind of 2 types of errors you can make. So you can predict that something bad is going to happen, let's say a violent incident, but actually nothing. And so you send someone to the scene, but nothing bad happens. that's an error, but it's not as costly as when you predict that nothing bad is going to happen, but actually something bad has happened. That's an error that's much more costly. So if you take those costs of errors into consideration, you can improve the subjective judgment that the police officers made by applying machine learning, not only to the questionnaire, but also to information about the criminal history of both the perpetrator and the victim. What's important, of course, when you do that is that you factor out variables that could easily introduce bias. So, for example, there is information about the victims and the perpetrator's race in the data set, but that is factored out in our models. So any factor that goes into there is, let's say, uncontroversial.
Wow, that is great. Also, moving towards your background in healthcare, how can machine learning in healthcare help us fast track future drug development?
So essentially, there's a lot of healthcare data out there that hospitals collect, but that isn't really used outside of, let's say, the hospital administrative procedures. Now, if you think about it, that data can include information as to what patients were diagnosed with. It can include information as to what medical procedures they underwent or what lab measurements they had. So, for example, a patient's oxygen level in their blood. So that data typically sits in a silo and is then not used in any further way. But you can actually exploit the data. And let's say you take all the patients having suffered from a particular condition, let's say heart disease, and then you aggregate all those features that you have about a patient. And then you see, okay, are there meaningful groups across the different patients? And if you have, essentially, you can apply deep learning algorithms to all your patients, and then you get out a couple of groups, and then you can see, are some of those groups clinically interesting? So essentially, clinicians can look at those groups and then say, oh, this is a particularly interesting group. And we should take this into account when we try developing future drugs. And of course, drug development is super expensive, as we of course know with the COVID situation in recent times. And so any way how you can reduce the cost of drug development by, for example, reducing sample sizes is going to be super useful.
Yeah, it's truly remarkable to hear you talk about machine learning and the intersection between machine learning and these two vastly different industries. Yeah, the police force and also healthcare. I know you've worked for 3 different companies since receiving your master's, and you mentioned that the 2 key components are messy data and the challenges of interpreting models. So can you please explain more about this?
Sure. Messy data. So any listener to this podcast who's a data scientist will know that what you learn during your studies is always based on super clean data. You have no missing values. The features are super clear. You don't have to integrate data from different sources. Of course, in practice, it's the polar opposite. So what do I mean by missing data? I guess the first issue is you have to get the data. You have to find out where the data lies and whether it's been processed in any particular way that might bias the data. And then you have to integrate different data sources. So if you just think about taking data from one database, data from another database, and then you have to do a merge on those data tables, a lot of records won't be matching up. And so the question is, what do you do with that data? Do you just discard it? That's one issue with messy data. Another issue is, of course, sometimes it pays off to find out how the data was generated. So for example, if you have a feature that features very heavily in your model, that's kind of ranks highly in an important score, and then someone asks you about, okay, why is this feature important in predicting something or classifying something? And then, okay, you say this feature is important. I don't quite know why, or you try to give a reason, but then like someone who actually knows more about that feature says, yeah, but there was an issue when we generated that feature, or like it's not a clean feature. And then suddenly you're in trouble, like justifying your model, because a big part of kind of selling machine learning is you need to make your models credible. And of course, if you can base your models on data that are reasonably clean, then that's going to lend credibility to whatever results you can produce.
Wow, okay. Yeah, we talk about messy data and perfect data in schools when we're learning, we're given perfect data sets, but in the real world, it's more messy. So what did you learn in your studies in school that does translate into your practice now?
Sure. So in general, it's good to have a background in maths and to have a background in the inner workings of the popular machine learning algorithms. In practice, however, especially if you are working in a team that's not entirely composed of machine learning or data science people, but where you kind of come into a business and you try to integrate machine learning into that business for purposes that are not necessarily terribly sophisticated, no one is going to ask you about, okay, did you use this fancy new algorithm? What people are going to ask you about is, okay, you have a model. What features went into the model? What do your model results mean? And can we trust the model? And then if people do trust the model, how can we actually use this in practice? So knowing the background of algorithms does help in selecting which algorithm I use. It helps me in deciding, okay, these are hyperparameters that I want to tune. But I would never code up something like a gradient descent algorithm or some kind of optimization algorithm myself, but I just make use of high-level functions. So I just know if there's something wrong with the model, okay, I could go in there, but really I don't need it. The other thing I would point out is a lot of the time, what really matters is how you implement things. And so typically in data science and machine learning masters, you don't learn a lot about deployment, let's say, or dealing with messy data. And I think that is something that is very useful and that you can only really learn through projects or when you actually like apply things in practice.
Yeah, we're now moving towards talking about implementing data. And at Chambers, I know you specifically worked on making models explainable. So how do you do this and how do you make them contain business insights?
Sure. So one important way of making models explainable is, of course, to tell people what the input features are into your model. So very often it's more useful to just have a select few features that everyone can understand and that are fairly clean, rather than trying to grab every single feature you can from across the business. Because of course, as you can imagine, a large percentage of that would be terribly useful. That's the first aspect. The second aspect is once you have a model, whatever it might be a regression model, it might be a clustering model, ranking features by their importance. So people can really see, okay, this is, for example, if you want to cluster your customers, you can say, okay, the reason why we've put customers into this group is because of these two features, because they're the most important ones. I think another important aspect is visualizing your results. So with a clustering, for example, one thing you can do is if you have, 10 input features, you might not want to base your clustering on all 10 input features, but first carry out a dimension reduction. So you essentially compress all your features into two composite dimensions, because once you've done your clustering, you can easily visualize the results on an XY axis. And that often is a lot more important in terms of creating buy-in from people, from stakeholders across the business, than having the most accurate model that kind of contains all the information that is there in the data. Because if you think about what actually matters in the end, what matters is that people use your results. What doesn't matter is that your model is 100% accurate.
Yeah, no, that's great. That is true. So we at the Data Standard are building a community of data enthusiasts and data thought leaders where everyone's open for collaboration and for connection. And so I specifically want to ask you, what can our community do for you?
Sure. So I think the main thing I'm interested in is when you go into an organization, how do you create buy-in for data science or machine models? Because as people often say, a lot of data science projects or AI projects, if you want to be a bit more ambitious, tend to fail in organizations. And there are multiple reasons for why they fail. But I think one of the reasons is, especially in smaller organizations that might not be data literate or that are legacy businesses, you really need to create buy-in to any kind of data initiative that you have. And how do you create buy-in from people, from stakeholders who didn't have any previous exposure is a very complicated question. And you really only know that after, having obtained the practical experience, or if people tell you, what their strategies were to create that buy-in. I think this is where the community could be really useful.
Yeah, it's totally true. I think if someone else has gone through similar challenges as you can learn from them instead of going through these challenges yourself. We can definitely help. Yeah, exactly. Yeah, we can definitely help you. Yeah, work with you, collaborate at the Data Standard. And for more information on the Data Standard, you can find us at www.datastandard.io. This episode was also sponsored by Pandio, and they are innovating the tech space, and you can learn more about them at pandio.com. But once again, Sean, seriously, thank you for joining us, and I appreciate all of your input.
Sure. It was my pleasure. Thank you so much for having me.
Thank you.